Welcome back to Math Addict 59 YouTube channel. Try to make my screen go away if I can. Making a lot of videos today because we had our classes canceled. We're having a winter storm outside. 38 degrees, cloudy, and it is a winter storm. Woohoo! A winter storm only San Antonio would dream of. So you're going to be given problems where you're going to have to find a general antiderivative. This is a situation where if you are given a polynomial, or, well, for that matter, any kind of function, doesn't have to be polynomial, just make sure you understand that that function is probably not written with an integral sign. It's probably written like this, but not terribly important. But do make sure you realize that the antiderivative is also expressed as an integral. So just make sure you realize that in the case of a polynomial, you're going to realize upon what we talked about last time that if your function is a quadratic or an x squared, the antiderivative is going to be something of x cubed. But you probably also recall that if you take the derivative of x cubed, you're going to get 3x squared, whereas you're starting with x squared. So from that, you're going to also reason that you're going to have to express it as 1/3 of x cubed or x cubed over 3. And then you're going to have to go back and review your trig derivatives to find the antiderivative of cosine. That's about the best I can offer on one of these problems. Now, because it's a general antiderivative, you also have to understand any function or any vertical translation of that function will have the same derivative. So you have to account for that by writing plus a constant. Now, that's a situation where you have a general antiderivative. Now, you're also going to have situations where the problem is going to say, given f prime of x, get f of x if f of 1 is 6. This is where you're not looking for a general antiderivative anymore. You're looking for a specific antiderivative function, because only one of those vertical translations can have this point. So let me pick a different situation here. Let's say the function was actually f prime of x equals 2x plus 3 over x. So what you're going to realize is f of x is going to be x squared. Now, you might recall 3 over x is also known as 3 times 1 over x. And you're also going to recall that 1 over x was the derivative of natural log. So we're going to go ahead and write 3 ln of x. Now, traditionally, you should put an absolute value because 3 over x has a domain of all real numbers except 0. Whereas natural log only has a domain of positive numbers. So you have to account for the fact that negative numbers would still follow a natural log situation, but you would need absolute values. You would have a plus c. But you're also given that f of 1 is 6. So now you have to write an equation that involves f of 1. And this one should be pretty straightforward and not terribly hard to find c, but you do need to recall, don't automatically assume that c is 6 or whatever number it is. You have to go through the process. Now, in this particular case, I'm going to be left with 1 plus 0, 1 plus c is 6. Hopefully you recall from your previous lessons that natural log of 1 is 0 because e to the 0 is 1. In this case, c is 5. So now you would express your specific antiderivative as, let me write it down all together now, f of x would be x squared plus 3 ln of absolute value x. I'm not sure if you really need the absolute value, but I'll leave that as a question up to you. Plus whatever I just said it was. I'm old and I forget things easily. It is that 5. So that's just a quick overview on what to do in regards to general antiderivatives and specific antiderivatives. Have a great day, and I'm going to post a lot of these today. Thank you.